to solving a system of equations. I thought that was supposed to be Algebra 2 stuff. Wait a minute, solving systems of equations, you did that in Algebra 1. Why do I already know that you guys are somewhat terrified of solving this problem, and yet technically, in some ways, it's really just needing math that you learned back in Algebra 1. Okay, fine. Algebra 2.
I love change.
Good. So, why are you scared of this problem? Who, look at this. Who's scared of solving x dxr? Okay, cool. I knew that. I knew that. Why are you worried? What's wrong? Okay, it's a lot. You don't like what's there. Okay? What would make it easier? Okay, just get rid of the cosine. Sure. How do we get rid of the cosine? Actually find it. We can't just like take it out and be like, no cosine. But we can go ahead and now. Part of me hates doing this, but it's okay because I care about you. Cosine of 24.3. Okay? Gives me a decimal of, ready? Negative 0.911403. Three. I'll do 1, 2, 3, 4, 5, 6, 7. 7 is the number of completion according to the Bible, so I'll do 7. Okay. Why am I doing so many decimals? I'm trying to keep it as accurate as possible. Would I be doing these decimals? No, but I'm trying to make it nicer on you. So I have this as the coefficient of, do you guys not like all the x's either? Does that make it kind of weird for you?
Yeah.
Okay. So let's just make these guys, let's make these guys.
I don't like subscripts.
No, I know. I'm going to take it all out. Let's see. I'm trying to figure out who's who. So I have XR. We'll just name him. Yeah, I guess we can, but it's vector red. That's okay. We'll do R without the arrow to stand for his magnitude. I don't like it a lot, but it's okay. It's okay. So we'll call that R. Okay? And then we'll name this guy B without the arrow to be magnitude. So I'm going to use B in just a second for that guy and that guy. Use R for this guy and this guy. You say you don't like the cosines. I say fine, they're just decimals, whatever. All right, so cosine of 44.5. And then I have 0.71, 3, 2, 5, 1, 2, 3, 4, 5, 0, 4. There we go. Equals 0. Is that less scary?
Yes.
Okay, so let's just get decimals down here too. Yeah, double check my decimals though, make sure I'm right. Okay.
I did this description, but I forgot. Why is the first one is the R included negative?
We have to go back to the picture for that. Negative in math, especially in physics, usually means opposite direction. Because if you're headed positively versus negatively, you're headed different ways. And so think that x is negative here compared to that x. And then the y's are both positive. And we did that, right? The yellow, we put that in. Let me get this last decimal just so people can finally be rid of all the sines and cosines. We get 0.70090993 equals 20,240. Aha! Is that a prettier system?
Yes.
Okay. Priyanka, let's check out the cables. My bet is that even though they're both pulling up, they're pulling horizontally opposite ways. See it? So the blue one, is pulling to the right and up, which if we were to talk about like an XY axis, that's in the first quadrant, that's positive, positive. So that's why the blue one has positives. But the red one, it gave us a first quadrant angle, which is going to be all positive, but he needs to head left and up. So I had to put in the negative. The other way of doing that is I could have done 180 minus 24.3, which would have been 55.7. And then that would have naturally have given me a negative cosine with a positive sign, and I wouldn't have had to have thought about it, but I would have had to have made that supplementary angle to begin with. So I said, whatever, okay, I get it, 24.3, it's going to give us the right triangle, but I need it to head left and up, so I put left and up as my side. That makes sense, kind of? And then Emily's question yesterday was, why am I not setting equal to a negative 20,240? Because the crate is pulling down. But we're not actually solving for the crate. We're solving for what the cables are doing together as they pull to offset the crate. And that is pulling up. what do you need to be able to do to lift something? All you have to do is match the forces that are trying to hold it on the ground. Yeah.
So now every time we see this, we just change it. So we're able to just change all.
If you use first quadrant angles for everything, if there's not any obtuse angles that already have negatives and positives attached, but if you're just using first quadrant angles, you can look at the picture and make it the correct positives.
Okay, and then so you just plug that into your calculator, and then why did the R's go after the other one?
Oh, because I was trying to make it look more like what you guys are used to for systems of equations. Usually you have number x, number y, number x, number y, and you just solve.
Okay.
So then I was putting these little variables at the end. I was making the cosines just the decimals they truly are at the beginning, so that it's more familiar. Yeah.
I don't understand where you got the x's from, the xr, the xb.
Oh, that was from the formulas that Jaden was asking yesterday when we were given magnitudes and directions and we wanted components. We have to use that formula that says, hey, we can always make components as long as we have the magnitude of the vector times the cosine of the direction and the magnitude of the vector times the sine of the direction. And so we did that for both of the vectors based on their magnitude. And I just called it magnitude of the r. I said x like I don't know him. Magnitude of r's and magnitudes of blues. Or of reds and of blues. So since we didn't know, we're trying to find the tension. And the tension in this case is the how muchness that the cables have to be pulling or working, the tension on the cable, but the tension is our magnitude this time. Whereas in other ones it might be velocity or force or work or something like that. This time it's tension, so he's this guy that I don't know for either one. And that's why I have these variables I'm trying to solve for, because if I find them, then I can find the tension, because they are the tension. Okay.
I'm still very lost.
Despicable Me yesterday. If someone talks about a vector, they talk about how much you turn and how much you go out. But our math is much easier adding, subtracting, and multiplying if we just have the components instead. And the only way to get the components is to think back to right triangles. And so in our notes we thought back to right triangles. But I can't go back in. But that just means that I lost you back here when we were actually getting the components. I did it the weird geometry way, and I said, oh, but look, it's so much easier if you get components.
Because I got those and those ones really easy, just with the little formula things.
Okay, so you get that there is a formula behind it, right?
Yeah.
But these ones, we knew the magnitude, which in this case, they told us the tension. The problem was, in this one, they didn't tell us either tension, and so we had two unknowns that we have to find. We don't know this guy, and we don't know that guy. If I was to actually put it in proper notation, I was trying not to confuse people out. This one would be, see it, that would be red. I just used X because I was trying to downplay how much was going on. And then this would be, yeah, so your brain is looking for the technical, and this is the technical. But then I'm just making them these little baby variables to make it easier. Okay. So with that, how do we solve? Well, can't I just go ahead and, what do you guys want to solve for? R or B? We have to solve for one of them. Plug in. R, okay. So if we were to solve for R, then we're going to go ahead and subtract B and then divide, right? So subtract the 0.7. Now, do you see why I didn't like going to decimals? Think about me. What am I having to do right now that I don't like?
Right.
I have to write all these annoying numbers. Is it working? Yes, totally. It's fine. But I'll show you what I would have done in just a second. And then once you have this, plug it in, plug it in. Remember, right? We solve for one, we plug into the other. And when we solve, aren't we going to have only B's left? So we're going to have 0.4115144 times. If you're getting annoyed by all the numbers too, hang in there. I'll show you what I would have done. I know you don't like it, but can I get all these numbers to be a new number, and then can I add to that number and then divide? Yes. So I'm going to do my 0.411, which thank goodness I have it here. I'm going to multiply it by that negative 0.713, which thank goodness I have right there. And then I'm going to divide it by the .911, which, oh, I have up here somewhere. There it is. Okay. Oh, that's 6. Let's do 7. There we go. You guys see it, right? I can combine my like terms with my nasty decimals, and I can solve by dividing. So I would go ahead and do that guy plus my .70.
I'm not liking this.
I
Why
know.
is the number so small?
Because they're decimals.
1, 2, 3, 4, 5, 6, 7. Ah, but is it going to be small now, kid?
Something like 18 something.
Because you're seeing it's 1-ish, but it's a little bit more than 1-ish, so it's going to be a little less than 1-ish. So good practical math, right? 20,240 divided by that big old decimal. B is equal to 19,785.83.
What does that stand for?
Retention of the
How many pounds of tension? Yeah. How many pounds of tension is actually on that cable as it's pulling up? So it's not bearing the entire load, but it's bearing a lot of it.
So different RN.
Now we're just going to subtract the B from the.
Well, I guess we could do that. We could plug it in and subtract and then divide, or we could just plug into the R expression way up here, right? So I could do that negative. Oh my goodness, I have to go find all that. I'm just going to type it in because I do enough decimals. Negative 0.713250 times this big old guy that I just found. There it is. And then divide it by negative 0.911433. Whew. And I get, no, not 0.
It's going to be like 20.
15,484. It's going to be a little less, Alec, because the angle is a little bit lower. That should logically kind of make sense. If the angle's higher, you're bearing more. If the angle's lower. R is equal to 15,484.09.
Wait, is R just the back of the
I just plugged in. So it's the magnitude, it's the overall tension on the onto the cables.
I did not see the
Huh?
I didn't see the
Oh, yeah. Sorry. So then I just plugged in. Because in substitution, remember, you always solve for one, then you have to go back and then solve for the other.
I don't see
Now, is that valid? Yes. And not all the problems are this messy. There are so many different cosines and magnitudes, and we have to solve a system in so many decimals. I'm just going to show this to you quickly for those of you that might be interested in not having to do all those decimals in your calculator. The other way is that you could have actually kept in all of those cosines and sines and not been scared of them. Now that you realize they're really just numbers, you could have looked at all those cosines and sines and seen that. Don't worry, you don't have to. You can use all those decimals. It's fine. You're only going to have like maybe 1 or 2 of these in those word problems where there are so many decimals. But the other thing that you could have done is that you could have solved for R using the sines and cosines. And so you could have said that R was equal to, without having to do any number crunching, I could have subtracted the B cosine 45 divided by the negative cosine of 24.3. I didn't need to use this. I didn't need to do any decimals. I could take that expression and plug it into the other guy, which I know you wouldn't totally love, but check what happens. Cosine of 44.5 all over negative cosine of 24.3 times sine of 24.3. Oh wait, isn't that tangent? Plus V sine of 44.5 equals 20,240. Still haven't done any number crunching. I could go ahead and factor out a B, and I would have cosine of 44.5 tangent, well, that's a negative, positive over negative. Tangent of 24.3 plus, bless you, sine of 44.5 equals 20,240. I could divide all of that to the other side to solve the
Bless you.
check it. I could have gone straight to B. Now, maybe you like it, maybe you don't. Maybe you would much rather do all the decimals. It's totally fine. To be honest, you could probably go to like 5 decimals and still be plenty accurate as far as your answer goes and as far as error goes. But this is what I would have done to hopefully get the exact same answer that we just got. I'm just going to make sure that I got it right because, to be honest, I trust this work more than all that nasty decimals because I didn't lose anything this time. But I'm going to use that. How do you get to the nifty fraction since we're totally using our calculator all chapter long and the fraction makes it so I'm not making mistakes? Alpha y equals enter. And I'm going to throw that 20,240 all over my negative cosine of 44.5 times tangent of. You guys have the answer that we had a second ago, right? To double check.
I have an easier way of getting to the fractions.
Oh. Ooh,
It's
easier way?
It's alpha and then like the x button. So if you get alpha x, mine goes to the fraction.
So it's the same amount of steps.
Well, I guess technically it's 2 buttons versus 3 buttons because mine's alpha y equals and then enter. So you can do alpha x instead? That's cool. Has like a link to it. Did I get lost?
Huh? You gotta hit alpha. It's because you're using boomer
It's
text.
second x.
Ooh.
Yeah, it's second. What?
No, it's alpha. Alpha x.
No, I have it in alpha x. There is no
I
alpha.
don't trust my math as much as I thought.
There's no alpha.
Oh yeah, you have boomer. You have boomer text.
Oh. It's negative, isn't it? And a negative over a negative is a positive. And that would be a positive.
No.
Oh, is that my mistake?
Why is it?
Because you have to subtract and then divide by the negative. I forgot to subtract. You subtract and then divide, so there's a negative over a negative, which makes it positive. That was my bad. There we go, stick away the negative. Does that work? What was it, 19,785? Is that right? Yes. Sweet. Man, one little negative messed it up that much. I have like 52,000 something. I'm like, or 53,000. I'm like, that doesn't make sense. The entire crate, if you're lifting straight up, would only be 20,000. That's kind of nice about these problems is it's somewhat logical. If you guys are thinking through the forces and if your brain at least somewhat works in a physics-ish sort of way. But anyway, yeah, it's pretty crazy that the load is only 20,240 and yet the red is carrying or has a tension of 15,000 pounds and the blue has a tension of 19,000 pounds. But they still are needing to work in tandem because maybe the blue has like max capacity or it can't rotate at any further angle to carry any more of the load. So if you tried, that box would go crashing down, the crane wouldn't be strong enough, and then that would be bad. Or at least it wouldn't be able to lift it. Have you guys ever watched, is it the History Channel that has like the gold rush people?
Yeah.
Or Discovery Channel? Like sometimes they go to try to like lift a boulder or something and it's too strong for the actual bulldozer, it's too strong for the crane, and then you see the entire like equipment start to list because it can't lift it. That's kind of what would happen if this blue one, if that's its max capacity, or if it can't rotate, if it needs to be at an angle to lift.
It's like fishing.
Huh?
Fishing.
Yeah, if you get pulled in instead of pulling out.
Yeah.
You could think of it that way too. Alright, anyway. Let's tackle this one. This one's a nice simple one. This is the one that was like that even that we saw yesterday. Then I'm like, oh guys, this is a word problem. The work's gonna be awful, and it had like 2 steps. The key about this one is not the hard math to solve. It's getting the picture. With the picture correct, it's an easy problem. Without the picture, it's impossible, or at least it's super hard. If I were you, if you haven't yet already, label this the inclined plane. The one before was kind of like a team effort. You have a couple objects acting on a single object. The one before was like a team effort in the sense that like you had two different cranes working together. There are different ways that problem could appear. You have a couple acting at once. This one is just one situation. Something is being pulled up an inclined plane. Physics would always call it an inclined plane. Something's being pulled up or it's being kept from sliding down. It's being held. Sometimes you're actually pulling. Sometimes you're just keeping it from falling. So what do we know? A force of 600 pounds is required. That sounds like a total, like a net. Is required to pull a boat and trailer up a ramp inclined at. Okay, if it's inclined, they'll always tell us what the incline is. You guys have ever gone up the grapevine? There are all these signs about what kind of grade it is.
Oh, yeah.
Talking about the incline. Find the combined weight of the boat and the trailer. The combined weight of the boat and the trailer. Okay, so we have to figure out what this picture is. And I'm going to actually make this picture way more general because right now there's a boat and there's water and there's, okay. The general picture for any inclined plane. You have an incline. You have theoretically what like the horizontal ground would be. Yes, you have this little angle that they actually give you, but to be honest with your object, whatever it is, I always make it a box. The object on the plane, on that incline, I'm actually more focused on him than I am out here. So I actually need to think about what's going on with his triangle. And his triangle, I have one force going straight down. I have one force going perpendicular to the surface of it. Like if you were a little mouse underneath this crate, you'd be squished. Why? Because there's force going on against the slope. Right? So I have force against the slope. I have gravity, which is pulling straight down. And then I have, there we go, the force that's being required to pull or to hold it. Because naturally, if this thing, well, as long as it wasn't so heavy that, well, I guess even then that would be the force here. Naturally, what does this want to do if it's on an incline? Yeah. Anybody in driver's ed, which way do you turn your wheels? That's because naturally, if your brakes go out and you're on a hill, it's going to go down. Right? So, the nice thing is you don't even really need to understand totally everything that's going on, but let me show you something that's the key to everything. Ready? Do you guys see that this incline is also inside the triangle? That makes life so much easier, because if we were stuck out here, you guys have to do all kinds of geometry to figure out really it belongs in here. I'm not going to make you go through all the geometry. I did that already with the law of sines, law of cosines, with the vectors the other day. We're just going to be able to use this right here. Now we just need to label it. If we can label this one single little baby right triangle, all we have to do is solve him.
Well, I know the little line at the very bottom is 600 pounds.
Because 600 pounds is talking about the pulling, right? And the pulling would be parallel to the slope. So this one is going to be our force to pull.
So 600 pounds.
That's our force to pull. In this picture, yeah, we can label that with 600 pounds. That would be this little guy.
And then we can do thing, sign. And we can do a sign.
And what are we supposed to be finding, though?
The combined weight.
Of the boat and the trailer. That's acting on that little wheel
So
right there.
all we're
Right?
trying to do is we're trying to find the line.
You could think center of mass if you were talking about any other object besides like a boat with a little wheel. Are we talking about the straight down, or are we talking about the against?
The against is the weight. Wait, no. Gee, no one's talking. Straight down is gravity. But gravity is always equal to the force.
This would be our weight, and this would be our perpendicular force. So this is the force that's acting against the inclined plane itself, but this is the combined gravity and weight of the object. Because weight is dependent on gravity. True? Does that make sense?
Mm.
And it's kind of hard because we only have this one example. If we were to look at other inclined planes, we could ask, or we could see them asking for different things. For instance, like in your homework, you guys have those numbers you're supposed to do. It's an 80 something, a 90 something, and a 190.
91.
I don't remember which one it's asking for you guys.
What can?
Okay, which one did I give you?
85, 91, 96, and 101.
Okay, so 96, they're calling F the force to pull. Good, I labeled it F. They're calling W the weight, which is the force of gravity, is the combined weight. And then the other one, if they were to ask for it, which I don't think I gave you one that did, would just be called the force against the actual split, or against the ramp, or against the plane, the incline. I called it perpendicular because we would call it like the normal force, or we would call it the orthogonal force, or we would call it the, so I just did P for perpendicular. We could do A for against, I don't know. But if you guys just understand, this one is your force required to pull or to hold it from slipping. This one is your weight, because you can think gravity is straight down. There is this separate against the ramp, I get that, but that's the combined. That's the combined or the net or the overall of what's going on with gravity trying and you trying. This is the combined resultant of what the object is trying to do versus what you're trying to do. And then you can see from head to tail, that's why it's the sum. But anyway, long story short, you don't even need to really understand all the vectors. All you need to be able to do is fill in the triangle, because check it. If you can fill in the triangle, right, you're good. Meaning, I have 15 degrees right there, and I have 600 degrees right there, and they want this one. I know it's flipped weird. But check it. What trig am I going to use to get to W if it's a right triangle with an angle and a, what side is this? Opposite.
Opposite over changing. Opposite.
Who's this?
Hypotenuse.
Hypotenuse, because it's the longest one across from the 90.
We can use thing, what do you call it?
Does that make sense? Why was that work in the problem so fast? Because it's literally one baby formula, but you have to figure out what are you doing, sine or cosine or tangent. If they gave you W and they wanted F, it'd still be sine, you would just have to rearrange it differently. But if they gave you the force against the slope or against the incline, well then you'd have to maybe use a tangent or use a cosine. But this one, mathematically, go through the steps so you don't make a mistake. What do I undo first? I mean, you could plug it in your calculator, but if I was just trying to get W by itself, rearranging, what would I do first?
Multiply the 6.
Nope, don't multiply 600. Multiply the W, because if you multiply the W, that's legal. And then what do I have to do in order to get the W alone? Divide. Yeah, just go through your steps. You don't have to like try to jump ahead in your brain. Just go step by step. Does that make sense?
2000.
You got it?
2318.221.
2318 the 22. Oh, got it. For the decimals. I thought you were making that.
You guys are always turning my rounding. They're so busy.
And we're doing. But see, like, wasn't that math so much easier? But the picture was so much harder in some ways. The other one was like, whatever, get the components and add them. But then it was so hard because we were missing like tons of different things, and we had to do a system of equations with lots of decimals. This one, the math was easy, but the picture was hard. But if you remember, or if you study, inclined plane matches to this one baby triangle. As long as you plug in and use the right trick, the math is easy. That's kind of what physics is in some ways. Yes, there are usually lots of decimals, and yes, there are lots of different angles where you have to be using your calculator with trigonometry, etc. In some ways, the math is easy. The concepts are hard. Now, the math can get much more complicated as you get much deeper, but that's kind of the intro. Now this one might seem ridiculous, but it's actually not that bad. Remember I said we did the hardest one at the beginning of yesterday.
Good job.
Now, I know I made it small, but I'm going to try to draw it out. A commercial jet is flying from Miami to Seattle. We got it, right? Cool. The jet's velocity with respect to the air is 580 miles per hour. Its bearing is 32 degrees. Its bearing? Is that talking about north, south, east, west again?
No, it's 30 degrees, so it's like facing.
So he's coming from Miami, right? To Seattle. Bearing says from north.
West.
So then where is he actually headed?
That way. It's actually headed.
270, 300, 330. There's my 332. You guys see how I did the bearing from north? Clockwise, how we talked about bearing a long time ago. Does that seem to make sense? Yeah, my picture maybe needs to be bigger, but whatever, got it. The wind at the altitude of the plane, so the wind up where the plane is blowing from the southwest. We can say like in line with the plane, is blowing from the southwest, from the southwest. So here's our south and here's our west. From the southwest, oh interesting, towards the plane. From the southwest with a velocity of 60 miles per hour. Wait a minute, he was supposed to be 580 miles per hour? Oh, stink. Hold on, if I'm trying to make this at least somewhat appropriate, remember how I said in physics we want to make it somewhat accurate? We could do 1, we could do 2, we could do 3, we could do 4, we could do 5, we could do 6. Okay, so he's going to be a little bit shy of 6 units. I mean, it's miles per hour, 600. So 600 miles per hour. I'm doing a little bit shy of that. So like 5.8. In some ways, I'm going by hundreds. And I'm only doing that so that I can make this 160 be somewhat accurate, because this little guy, I think he's a little too long. I need to make him 60. So 60, well, there's 100, and then go a little bit shy. So we'll do that, and then we'll go here from the southwest. Now, it's a little bit weird in that from the southwest, you might not know exactly what his angle is, but if it says from perfectly southwest and doesn't give me like any other angle or bearing, I can say, okay, it must be like a 45-45 kind of guy. It must be halfway. Okay. What are they asking?
They're asking for the velocity.
Draw a figure that, oh, hey, we already did letter A. Letter A. We have our plane going that way and have our wind coming this way. Cool. Letter B, write the velocity of the wind as a vector in component form. So I want the velocity of the wind in component form. I need magnitude, and I need direction, and I need those formulas out that we were talking about earlier, right? What's the magnitude of the wind?
6 miles an hour.
Magnitude is how much, and how much is miles per hour. So that'd be 60. But Sophia, we are going to have to use that 45 in just a second.
Wait, equals 60
Cosine. But now we need an angle.
45.
Okay, so we could do 45.
See, I have big brain.
What am I warning if I say could? There's another way, or maybe there's something else to think about. Why am I getting a yellow marker? What did I do with the cranes once I picked a first quadrant angle without consideration of direction? Positives or negatives? Good. So let's look at this. If we look at this little guy, if we break him into his components, what are both of the signs going to be? Why positive? Because I'm headed to the right and I'm headed up. So it's okay for this guy to be positive, positive. Ooh, what am I getting you ready for?
The next one.
Okay. Letter C says, now do it for the jet. The velocity of the jet. I'm not using V because wind has a velocity and a jet has a velocity. Hey, if all goes well, maybe at the very end I'm just adding them in my calculator.
Why not? This is going to be
Okay, who's my jet's
580.
magnitude? 580. Cosine of
332. Wait.
Here's the struggle.
Oh.
332. I know, you're right. 332, doesn't that normally land you in the fourth quadrant? Could we think about what he would be in the first quadrant and then put our own signs on it? Is that okay?
Yeah.
Okay. So if he's 332, how much past 270 is he?
60. Wait, 62.
So could I just do 62, do the first quadrant variation, and be like, you know what, that bearing thing really messes me up? Because bearing has him up here, whereas normally it would be down there, and I think my signs, Let's just get our yellow out and say, hey, what's he doing? Going left and then up. So that'd be a negative and a positive. Does that make sense? I was thinking about 45 and being in the first quadrant, and I made it to the right and up. So if I want the left and up, it's going to be easier if I just stick to first quadrant angles and I make the signs myself. That's just kind of like a little hint for me. If you try using the bearings, good luck. You have to kind of reorient all your positive, negative understanding. Letter D says, what is, now here's the weird part. Letter D says, what is the speed of the jet WRT means with respect to the ground? This sounds really hard and complicated unless you realize it's just saying like, hey, if you're on the ground looking at the jet and measuring how fast he's going, it's how fast he's trying to go, plus how much the wind is throwing him off, adding or subtracting. You guys have been flying somewhere, right, where the wind is working with you, pushing you to go faster, or flying somewhere the wind is working against you, takes you longer. This is really just saying, add the two together. It's just asking for the resultant. Snazzy words just saying, hey, put it together.
But is it really like pointing?
Well, it's not directly against it, so it's not directly taking away. But is it taking away some? Yes. And we'll be able to see that as soon as we, yeah? But can't you just throw that in your calculator because we're adding the x's with the x's and then the y's with the y's, right? I'm going to go ahead and do that as Priyanka asks her question. What's up? Vector.
As a vector.
Yeah. So a vector has magnitude and direction, right?
Yeah.
So a vector is not just the direction, it's also the magnitude as well. So the little arrow is the velocity. And then if I was to put these two together and then connect them, that would be the speed vector. I think you're getting confused by miles per hour with miles per hour, right? Like miles per hour is a velocity. Yeah, you have it. Guys, once we have this, could we do magnitude? Could we do direction with it? The answer is yes. Priyanka, I can answer that question because I think you're still asking. I was just trying to get the decimal. All right, guys, we've gotten through our word problems, so I'm spot checking them tomorrow after we go over questions. Have them ready and set up, and then if you need to ask something, we'll do that before I spot check. Oh, that is not a negative. Sorry, Priyanka, go ahead. It shows a direction, but it also shows you the overall. So I wouldn't summarize it with direction, but it is doing components.
Just declare notes.
You guys still talking about Frozen?
No, we're not talking about it. We're singing it.
Oh, sorry, Joe. My rebuttal to why
This would be the final.
Why can't
final
you?
kind of
You guys are being dumb. There's a standard of unit that they use to figure that out.
I don't know how to do it.
Hey, so you know how like.
Do you know what I mean by standard of unit?
I know, but
they do like.
There's an object
okay, but that's
in the
assuming
movie.
they're using the same wavelength
Yeah,
as we do.
Oh, you're thinking about a movie that has a woman with ice powers. No, I talked about the canon of
Kevin, they figure out, look, there's a nutcracker right here that's like guaranteed in the movie to be 12 inches tall. So they say 12 inches, and they say, oh look, the nutcracker, he's next to the nut. That means 5
Olaf,
of these.
your picture would be like 2 feet tall. Picture is bad, right?
Yeah, but it's fine.